So when it comes to SDN, how is it implemented in real world? In other words, what type of solutions exist so we can leverage software-defined networking in our environment? Well, first of all, data center is the #1 space in the enterprise realm where most of the technological innovation has happened over the past decade or so, especially when it comes to virtualization and automation. And the way data center SDN solutions operate is they're designed for facilitating east-west traffic flow. So what do I mean by east-west traffic flow? So if you look at this particular topology here, we got a couple of core switches, and then we got these access switches that have the different network endpoints like servers plugged into them, and on the servers you may have different VMs that are running. Within the data center, majority of the traffic flow happens to be between the virtual machine themselves. That's what's called east-west traffic flow, meaning the traffic stays within the data center, but the traffic needs to be able to communicate with other servers and virtual machines that are located within the same data center for different reasons. And I'm going to give you some of those details momentarily. Now, there are different data center SDN solutions that exist out there. One of the most popular ones that is open standards based is called OpenFlow. And what we have here is the control plane is fully centralized on the controller, and it's responsible for building the forwarding plane of all the network devices that are connected to that OpenFlow controller. Now, Cisco has its own flavor, of course. It's called ACI, or Application-Centric Infrastructure. And the controller, which is at the heart of ACI, is called APIC, or Application Policy Infrastructure Controller. It's very elegantly named, and Cisco rarely names things elegantly, but here I think they did a great job because the whole idea is application centricity. And I will explain to you what that means as we continue moving along. The next big SDN solution is the campus or branch SDN solution, and this is designed for north-south traffic flow. Now, let me explain what that means. So as you can see, in a typical campus network, you have a 3-tier design. You got the access, you got the distribution, you got the core, as you're seeing here. So, for example, this phone right here, let's say it's a voice over IP phone. If I want to call somebody outside of my organization, traffic flow is going to go from the access, through the distribution, through the core, out to the internet. And that's what's being referred to as north-south traffic. And then when the traffic comes back, it's going to take the same path back. And this is the north-south traffic flow. As you can see, this is a very different type of traffic profile as opposed to the data center profile. Data center, a lot of traffic east-west within the data center. Within branch, north-south. Hope that clarifies why we have different type of SDN solutions out there. Now, the first solution that Cisco had a couple of years ago, it was called APIC EM. So they took the ACI APIC and they added a keyword enterprise module, or EM, to make it more branch-centric. And it wasn't just a name difference, but they actually changed a lot of the functionalities within that controller to make it more campus network centric based on that 3-tier north-south traffic flow. But that was legacy. It's now called Cisco SDA, or Software Defined Access. And sometimes it's also referred to as IBN, or Intent-Based Networking. And at the heart of SD Access is DNA Center, or DNAC. And DNA stands for Digital Network Architecture. It's a marketing term used by Cisco for the campus controller. So DNA Center is the controller. So what APIC does in ACI is what DNA Center does in SD Access. And finally, for the wide area network, now once again, if you think about a WAN design, WAN is very different than data center and campus. The whole reason WAN exists is to allow the data centers and the branch locations to talk to each other and to connect with each other. It's the connective tissue that allows the branches and the campuses and data centers to all talk to each other. That's why wide area network exists. Once again, a very different type of traffic profile and a very different type of architecture. The big one here is the Cisco SD-WAN. It was formerly called Viptela. Viptela is a very popular SD-WAN company that Cisco acquired a couple of years ago for north of $600 million. And it brings tremendous SD-WAN capabilities into the Cisco portfolio. As of today, the Viptela solution has been 100% integrated into the Cisco portfolio. Most of the Cisco routers within their routing portfolio today are SD-WAN capable. In order to manage the wide area network solution, there are two different types of controllers you can use. You can either use the vManage controller, which was acquired through the acquisition of Viptela. So this was the original technology that Viptela had designed, which was basically a controller for managing Viptela WAN fabric. But what Cisco allows you to do is you can still use the vManage controller if you wanted to, or you can use the Cisco DNA Center controller, which also allows you to manage the WAN in addition to managing your LAN or your campus network. So it's really interesting that Cisco is kind of bringing it all together now to make it a lot simpler for users to manage their environment. And one last thought on this topic here is, keep in mind that SDN controller could be available in a virtual form factor as a virtual machine or a VM, or it could also be available as a physical appliance. Now, the most popular way of acquiring SDN controller is a physical appliance. For example, Cisco ACI and Cisco SD Access requires you to have a physical appliance. And the reason Cisco prefers you to have a physical appliance for managing your devices is because of the stringent requirements as far as the compute resources, the memory resources, the storage required for managing the entire network fabric. Physical appliance works better because Cisco kind of designed that appliance for that purpose. But as the world is increasingly becoming virtual, Cisco is seeing that trend and are slowly moving in that direction to allow customers to have a choice of just installing a VM on the hypervisor of their choice. Hope you enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.